Hi all, welcome to Elite. Now, the second part of the question says that we want to find the weight of the minimum weight of the boy such that the man can climb up to the point B. Let's solve it. First of all, analyze the free body diagram. So, here is a normal reaction NB, and there is a friction FB, and the weight of the man is W by 2, and the weight of the ladder is W, and the normal reaction from the end A is Na, and the friction is Fa, and the weight of the boy is G. So these are the forces acting on the system. So let's solve it. So first of all, we can do summation of Fx equal to 0. So this is one force and this is another force. These are the two forces in the x direction. So we can write it as Nb is equal to Fa, because this is acting towards the right and this is acting towards the left. So I just equate it, and we know that Fa is equal to mu a into Na. So we get a relation between Na and Nb. So this is the first equation. So now we can do the summation of Fy equal to 0. So here is 1, 2, 3, 4, and 5 forces acting in the y direction. So we can write summation of Fy equal to 0. So Fb minus W by 2 minus W plus Na minus G equal to 0. So this is this acting upwards, and these two forces are acting downwards, and this is acting upwards and this is acting downwards. So we can simplify it. Mu b into nb minus 3 by 2 w plus na minus g equal to 0. So mu b nb plus na is equal to 3 by 2 w plus g. Nb mu b plus, and we can get na from here. Na is equal to nb by mu a, so I can write it here. So nb by mu a is equal to 3 by 2 w plus g. So mu b is 1 by 3 and mu a is 1 by 2. So we can substitute it. So we will get nb by 3 plus 2 nb is equal to 3 by 2 w plus g. 7 by 3 nb is equal to 3 by 2 w plus g. So this is our first equation. Now we can do summation of moment about point A is equal to 0. So summation of moment about point A is equal to 0. So first of all, this these three forces does not produce any moment at point A. So this weight W produces a moment at A, and this distance is 10 cos 45. So W into 10 cos 45. W into 10 cos 45 plus, so, and this weight W by 2 produces a anti-clockwise moment at here, and this distance is 20 cos 45. So W by 2 into 20 cos 45, and this force NB produce a clockwise moment at point A, and the distance is 20 sine 45. So this is minus NB into 20 sine 45, and this force also produce a clockwise moment at point A. So we can write FB into 20 cos 45 minus FB is equal to 0. So we know that cos 45 is equal to sine 45. So we can cancel this out. So we can simplify this as 10W plus 10W minus 20 NB minus 20 FB equal to 0. So 20 W minus 20 NB minus 20 into mu B NB equal to 0. So we can cancel these 20s and we will get W minus NB is equal to mu B NB. So W is equal, so we can get W is equal to NB into mu plus 1. It is mu B plus 1. And from there, NB is equal to W divided by mu B plus 1. So mu B is 1 by 3. W is equal to 1 by 3 plus 1 is equal to 3 by 4 W. So we get NB is equal to 3 by 4 W. Now we can substitute this NB in the previous equation, this equation. We can substitute NB in this equation. So let's write it. 7 by 3 NB is equal to 3 by 2 W plus G. So NB is, so we got NB as this. So let's substitute it. 7 by 3 into 3 by 4 W is equal to 3 by 2 W plus G. So on simplification we will get 7 by 4 minus 3 by 2 W is equal to G. So it is equal to 1 by 4 W is equal to G. So we got G is equal to 0.25 W. So this is our final answer. If you have any kind of doubt, please ask in the comment section. Thank you.